HVAC Temp Rise formula for measuring airflow CFM reveals whether your system is moving too much air per ton and hurting dehumidification. Fix it fast by adjusting blower speed, adding controlled restriction, or correcting oversized ducting. To measure and correct high airflow per ton, start by calculating cubic feet per minute using the temperature rise formula. CFM equals 350 times the tonnage divided by the temperature difference between supply and return in degrees Fahrenheit. Take accurate supply and return dry bulb readings at the grill and return boot, then average multiple points to eliminate stratification errors. If your measured CFM per ton exceeds the target, typically between 400 and 600 CFM per ton, depending on design intent, first verify static pressure with a manometer across the coil and motor. Elevated total external static pressure often means the control strategy or duct sizing is wrong. Lower blower speed in small increments using the manufacturer motor tap settings or an electronically commutated motor control. Then remeasure CFM and temperature split after each change, so you do not overshoot and create comfort issues. If speed adjustment is not available or insufficient, add a calibrated restriction device, such as a fixed orifice flow hood balancing damper or a properly sized variable air volume box at the supply plenum to reduce flow without introducing excessive noise. Inspect ductwork for oversizing. Oversized trunks can make fans operate on the low efficiency part of the curve. If duct diameter is 2 inches or more oversized for the system design, consider modifying the duct or adding turning vanes and properly located balancing dampers to re-establish design, velocity, and static. Always check coil face velocity. If it drops below recommended values, coil drainage and condensate removal will suffer. Maintain recommended coil face velocities to preserve dehumidification. Revisit control settings. Reset thermostat fan control to auto. And if the system has a dehumidification cycle or humidity setback, coordinate blower reductions during the dehumid cycle so latent load is prioritized. Finally, after adjustments, document pre- and post-change CFM, static pressures, and temperature splits so you have a verifiable performance record and can justify any further duct or equipment changes. One of the most common mistakes is relying on a single temperature reading for airflow CFM measurement, which leads to inaccurate CFM per ton and poor dehumidification performance. Fix this by averaging multiple return and supply readings, using consistent probe locations, and verifying instrument calibration. One of the next frequent issues is reducing airflow without checking coil face velocity and condensate removal, causing coil freeze or drainage problems. Fix this by following manufacturer coil face velocity guidelines and monitoring condensate pan and trap after each change. One of the biggest mistakes is assuming duct oversizing only affects static pressure when it actually shifts fan operating point and reduces latent removal. Fix this by measuring total external static pressure, correcting duct sizing where offset exceeds 2 inches diameter equivalents, or using calibrated dampers and turning vanes to recover effective velocity. BigHomeProjects.com lists trusted local HVAC contractors who can perform accurate CFM per ton testing, blower tuning, and duct corrections for homeowners. Our directory helps homeowners find vetted pros and helps contractors get work by connecting them with local leads seeking specific HVAC airflow and dehumidification expertise.